I am Mariska van Steensel. I'm an associate professor at the University Medical Center in Utrecht, and I'm coordinating much of the brain-computer interface research at the Department of Neurosurgery. So in the intense project so far, but also in the research before that, we have worked with data from epilepsy patients who receive electrocorticography electrodes on their brains as part of their clinical treatment of the epilepsy. And with the help of these patients, we have explored many questions, including where to put electrodes, what the potential optimal size of electrode grids is, and we have learned a lot from that. And now we're ready to take the next step and put this into practice in a BCI implant. In our group, we like to use electrocorticography or ECOG electrodes, which are placed on top of the brain rather than penetrate the brain. Given the current knowledge, those are the electrodes that provide us with very good stability of signals, both in the short term, but also at the longer term. And we find that very important because our group really wants to develop technologies that are potentially scalable and clinically applicable. And you can imagine that if you are going to widely apply BCIs for patients as a clinical solution for their impairments, then stability, long-term stability is going to be crucial. Nowadays, we have access to more advanced BCI technology, better decoders, so we can offer better functionality for users. Our current research is really aimed to demonstrate that it is possible. We try to develop this technology for people who have lost the ability to move or speak due to diseases such as ALS or due to a brainstem stroke, or people who have lost the ability to move their upper limbs due to spinal cord injury. There are existing solutions for communication, for control of computers for these people, such as eye gaze devices or voice control. These devices are not always a good solution for people with this kind of impairments. And therefore, the ability to use your brain signals only without the need to use residual movements to actually connect with the world, that's a very big promise of BCI technology. So the brain interchange fulfills our needs in the sense that it is based on electrocorticography electrodes. It's a fully implantable system, which we find important characteristics for long-term and wide scalability of BCI technology. The additional feature of the brain interchange that we like is that it doesn't only record brain signals, but it also gives us the opportunity to stimulate the brain. We therefore will have the chance now to explore to what extent the additional feedback that the user gets from stimulating the brain, if that benefits the training process of BCIs and also the performance of the BCI. Yeah, so our research team has a very nice and very long-standing collaboration with the Cortec team. For already many years, we worked with them. And one of the goals of this collaboration has been really to optimize the characteristics of the implant that we're going to use in the intense study. Yeah, collaboration between industry and academia in the BCI space is crucial. In academic settings, we would never be able to develop the hardware that we can safely implant in human beings. So for that, we really need the industry. But in return, when the devices developed by the industry are used by academics in research settings with potential users of the technology, the data and the knowledge that is gained in these studies is crucial for the industry to improve on their technologies and to eventually together make devices that BCI users actually embrace. Within the Intense project, we hope to be able to implant a participant in the coming year or so. And we will then train this participant in several phases to effectively and efficiently use the BCI for control over digital devices in this case. And an important aim is also that we want to accomplish unsupervised home use of the device. This means that the participant is going to use the system without us being there. And that has two goals. The first is that we hope to provide a little bit of benefit to our participants who are so adventurous in participating in our research. But also we want to understand what factors play a role in the performance and the usability of the systems. And we can only learn about those factors once they actually start using it, outside of research sessions and without us being there.